the um, the review for the final. Let's do it. So, okay, so let's look at the sample final. That's a good place to start. Um, so close this and go here, and then uh, um, okay. So am I looking up? Oh yeah, so we have to go to here. We have to go here. And I did update a little bit for the ninth chapter. Um, so as I update this document, since I'm doing it um, on Google Drive, you should get the update right away. Okay, so let's do this. Um, Final review. Okay, so let's do it. Okay, so let's start with question number one. Okay, you have something called CDCI pipeline. So is that what's called CDCI? Yeah, I think it was called something else also. But basically, a pipeline is a CD. Yep, DevOps. Okay. I had a problem nowadays. I would use a different word. I would call it DevOps. Um, so where are we up to? Yeah, it's over here. So, um, okay. So I would say DevOps. That's really the word we use nowadays. DevOps, um, CD, CI, or pipeline. So what does CD stand for? Continuous what? I'm sorry? Say again? Continuous development, you said? Yeah. So one is wrong. CI stands for what? Continuous integration, right? So basically, the idea is that it's DevOps. So get it? Dev is for development, ops is operation. So CD is continuous development, CI is the ops part of it. It's the continuous delivery of software, right? It also can continue frequent delivery also means continuous development also. CI stands for commitment. Okay, all these things are wrong. Should be used with together the waterfall process. Is that why is that wrong? Why can't the waterfall process use a continuous development, continuous integration? Right, because the whole idea of continuous development is that you're always developing. Waterfall, you're waiting uh, till you've done all other stuff first. You're not doing continuous development, right? Should occur once every month. Uh, that's actually not true because the delivery is every month, right? Let's explain what I mean over here. In other words, the sprint is monthly, but the pipeline, now there's people checking code while they're in the middle of a sprint, right? But so the idea is the sprint is monthly, the um, but um, the daily check-ins of code are immediately built and deployed by the pipeline. Does that make sense? In other words, the whole sprint is a month, but every day the pipeline, let's say a couple times a day, right? Like I always get messages where I work. I get an email saying somebody just built this branch of the code, right? So it can happen multiple times a day, right? So Sprint is monthly, but daily checking the code are immediately built and deployed by the um, pipeline. Okay, so that's the reason why number 5 is wrong. Okay. Um, okay. A non-functional requirement. Okay. You all remember that is right. Let's see. So the correct answer here is, I already have it bolded, is it's usually implied from the functional one. Um, okay, it's not a unnecessary requirement. It's not a requirement that cannot be made to work, which is like, it says the word non. So I thought I could fool some people. Usually has a smaller scope than a functional one. Is that true? Why is that false? Why is number 4 false? Could you see it? Why does a non-functional requirement not have a smaller scope? Well, if it's non-functional, part of the definition is that it's more, it's like, so it usually and that's basically a non-functional requirement is something that if it doesn't work, then the program will be unusable. So it's actually bigger scope than a functional requirement, right? Has a, right, than a functional requirement. It actually has a larger scope, right? Because it affects the whole program, whether it's usable or not. And am I recording? I think I am, right? I'm recording. Yeah. Okay. Um, okay. It's not related to customer satisfaction. Of course it is, because it's important to the client. So that's also false. Okay. So you have to understand not just the right answer, but why the other answers are wrong. Okay? Okay, so here we have a diagram, and what type of diagram is this called? It's a, what's it called? Anybody remember this? It's called a use case diagram, right? As opposed to a use case table, right? It's a little bit different, right? And what does this do? What does this diagram show us? What are these stick figures over here called? Anybody want to volunteer? Uh, anybody?
The actions of the thing, like the customer can view items.
Yeah, but what is no, yeah, I mean, you're right, but we'll get there. First of all, what is this guy over here? What's it, what are they called? The stick figure. Well, actually, this is not really a person. It's a authentication. No, it's called a user. Use no, I'm sorry. It's called a actor. You nearly got me. Right, these are called actors. So those are actors are things which are outside the system which interact with the system. Okay? So the actor is, for example, over here we have how many actors in this diagram? We have 5 act good. We have 5 actors and we have a bunch of activities that this program provides, services, activities, whatever you want to call them, right? And what are they? These are there's 4 of these, right? And then the diagram, the box shows you what? What does the box represent? The rectangle?
The program itself.
Right, the system, right, we're developing, right? The program. And then the lines connect the actor to which services the actors are going to interact with, right? So basically, it's a pretty high level view of the program. Like this is probably like one of the first things you'll create or discuss when you're designing a program, right? So it's a very high level thing. You're just saying, what are we going to provide? Who's going to use it? What are they going to do? Right? Very simple steps. Okay, so let's now that we know that, so first of all, we know it's not number five because we just said it's a, what's it called? No one, come on. Just said, what's this diagram called? Use case, very good. Um, a PayPal is a service not actor? No, it's anybody outside. Here's PayPal over here. Anybody with this thing is an actor. Customer can only perform two activities. Nope, we see customer could do three activities. Oh, by the way, forget about this dotted line in the middle, or this include. We're not doing all that, right? We're just keeping it simple, right? Right, as we mentioned many times, you can make these things very complicated, and unless your boss demands you to do that, don't do it. You'll impress people just with what we learn in the class. Okay, complete checkout interacts with the most actors. So we have complete checkout and it interacts with one, two, three, four actors. So that sounds like it's the winner because that's why it's highlighted. Okay. So, so that is the, oh, credit payment service must log in and credit payment service, nope. It doesn't have anything to do with logging in. That's also false. Okay? Okay, so that's the number three. Okay? Okay, what kind of diagram is this? You remember what we called this one? Very good. Sequence diagram. What are these yellow guys up there called with the dotted lines coming out of them? They have a weird name. Um, Anybody want to guess? They're called lifelines, okay? Right, and it's a weird name. By the way, where do you start? Where do you start? Where does this diagram start and where does it end?
Or-
I'm sorry? I'm sorry, what'd you say? Well, actually, I always thought it started from the left, but it's not really I thought, but then I saw one that wasn't on the left. It starts from the top and goes down, right? Because it's showing you with the passage of time what happens, right? So the sequence is from top to bottom, and these well, we usually they're a different color, but these are red boxes. These red rectangles represent the amount of time this object is active. Why? I don't know. I mean, why do I care how long it's been active? I'm not sure why we care about that, but that's what it means. Okay, so basically, if you want to read this diagram properly, you would say that first a person tries to register with the register office. That's a funny name. Should really be a registrar, right? Then, okay, so that's over here. So first, the first lifeline or object encountered is register office. Then what what this lifeline does is it sends a message, right? This line, the solid line, is called a message, right? It says, hey, account balance, could you tell me if this student with this student ID owes money? And then um, you see the line over there with the dots? That's called what? A what? response or actually return message, right? So we send a message to this person owe money, and then assuming, well, this is explaining it, saying, well, if the student doesn't owe any money, then we could send a message to the class object to register the student, and then the the drama class object sends a response that I guess maybe we have to check to see maybe it's already full, right? So, okay, it's not clear exactly what the message is, what the return message is about. Okay, and then the registrar is done, right, in this diagram, right? So if you would look at this, which object has the long the and there's, remember, time goes from top to bottom, right? So which object has the most time?
The register of.
Yeah, right, exactly. Right, these are about the same. Why do we care? I don't know. But that's what it represents. The amount of time it takes to respond. Okay, I don't or it's active. How many lifelines are there? One, two, three. How many messages are there? Well, you could say two or three, I guess. One, two, three. And there's how many return messages? Two. Okay. So we're done with that example. Okay. Uh, okay, so basically what I did was I just summarized all the patterns that we did. I think we did all these. Iterator, factory. Yeah, we did all these, right? Sound familiar? I think we even did more than that. Well, did we do more than this? Factory, state. I think we did all we did, right? I'm pretty sure. Actually, decorator, yeah, we did. Okay, so basically, this is a synopsis of every single design pattern that we did. So basically, the strategy pattern, does anybody want to guess what it is before looking at the answer? What's the basic idea of a strategy pattern? In a very, very simple, synopsis for your job interview, somebody say, explain me in one sentence, what does a strategy pattern do? What does it do? It puts
Like,
what?
you put like like a colon in, like, so you run it, pass it along to the motion.
Okay. Yeah, that's good. Yeah.
Like one flexible class that allows you to pass the behaviors on to certain objects.
Okay, that's nearly there. Yeah. Anybody else? Okay, so I mean it's nearly there, but the idea is that instead of having an if statement within a object, we take the different behaviors and put them into a separate object, and then we pass it in. That's the part you were mentioning. But the idea is that rather than having complicated logic within the different behaviors within one object, we pass in we put the different behaviors into remove it from one object, put it into their own objects, and then pass them in. Okay, that's in a nutshell what the strategy pattern is. Right, so a lot of what all the design patterns do, all these do basic business is basically the big idea from all the design patterns, right? Is we always put things into other objects, right? We're always objectizing things, make them into objects. Okay, the observer pattern is it's similar to the strategy pattern, except that it is a strategy pattern, but it's a specific form of it, and it's so specific that they actually gave it its own name. So the observer pattern is the same idea as the strategy pattern is that you could have different observers, right? And there's different objects viewing the same. Actually, it is a little different than strategy pattern, because it's not really a behavior, but it's rather just different observers. So different types of observer um, who are really, really different than each other, right? But we could group them together as long as they implement a single interface, the same interface, right? So actually, the idea here is the real idea is to group different objects together as observers if they all implement the same interface. Okay, so as long as they're all doing this, have one thing in common, then we could group them together. Usually, that's usually the notify method, right? Traditionally, that's what it's called. Usually, the notify method is in the interface. Okay, so as long as they all do that, we can group everybody together. That's the observer pattern. Okay. The Why do I keep doing that? The separate objects, plural, that are then passed into encapsulating different behavior into separate objects. Okay. Placing algorithms into separate objects. Okay. Okay, now we're up to factory pattern. Now, the factory pattern, a lot of people confuse with the builder pattern because they're sort of similar. Okay, what does a factory pattern do? The factory pattern, what does it do? It controls which object gets created, right? Right, it's a way of controlling so you don't accidentally use the wrong object, right? So controls which class or which object gets created. Now let's just quickly jump to the builder with which it 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 doesn't control which object gets created. It what?
Algorithm.
Or actually it enforces, yeah, verifies that a correct object is created, right? Verifies, among other things. It does a bunch of things, but the first thing it does is, the most important thing that it does is verifies that, so it's only dealing with one object, right? Not like a factory, which returns different objects. The builder is only dealing with one object, but the same idea. It's building an object and making sure that it has correct data. Okay, that a object, verified the object has correct data before creating it. Okay, it also does, okay, well, that's basically what we're saying here. It also breaks parameters into smaller parts. Okay, so whenever I do that, into smaller parts. So to make clear the purpose of the parameters, right? So like we could have different methods. Like for example, we gave like an example for builder, we had like unimportant or optional parameters and necessary parameters, right? right? We had those type of methods. So you understood by looking at the methods which parameters were important. Otherwise, you wouldn't know what's important, what's not, right? To make clear the purpose of the purpose and importance of the parameters to the constructor. Okay. Okay, that's a little bit more than one sentence, but it does two things, so. Okay, getting back to the, okay, so iterator pattern, what does that do? That is a generic, provides a generic way of traversing through a collection without knowing, um, without knowing, um, the, um, the object, um, that contains, without knowing the container object. Does that make sense? In other words, like, for example, we don't care with the iterator pattern, we don't care whether the things are in an array, they're in a stack, we don't care. As long as we have this iterator pattern, we could go through everything that's inside of it. Okay? It could be, in any type of object, right? Without knowing the container, um, object type. Okay. Okay, so that's the iterator pattern. It's not used that much anymore um, because, um, well, if you do with C++, it's used a lot, right? Anybody familiar with STL? Uh, yes, STL, right? That has a lot of iterators, right? Reverse iterators, yeah, standard template library for C++. So that has a lot of iterators. It has like, I don't know how many, but that's if you go for a C++ interview, you're going to deal with a lot of iterators. Okay. Um, um, okay. What is the state pattern? Right. So basically, the idea of the state pattern, as opposed to um, the the state diagram, which we're going to do, right? It's a little confusing. We have a state pattern, state design pattern, and we're going to have a state diagram, right? So the state pattern is basically we place the behavior of an object into different states. In other words, what an object does at a specific time, like the example we gave was, let's say a car is in drive, what it does in the drive state, what it does in each different state is in a separate object, right? So for different, um, I don't know, for different conditions, uh, and not can have objects, um, separate predefined states for different, what would be a good word? It's not really conditions, uh, for different, um, object, um, I was going to say states for different object, um, I don't know, states, I guess, like, i.e., it's easier to explain than to, i.e., drive state, uh, for, for IE a car can have a drive state, a reverse state, and a neutral state. I hope people don't know how to drive, might not appreciate this, but this is the idea. Okay, decorator. Okay, so we've got state pattern, right? Basically what it does, right? We have right, and then there's always a question. I don't think we covered it this semester of how is the state pattern, if you think about it, it's really a state could really be thought of as strategy. So how is this different than a strategy pattern? What's the difference between a state and strategy pattern? So I don't think we covered it. But do we cover this question? I don't think so. But actually people discuss that. There's actually, I don't think we covered it this semester. So, but if you're interested, you can look it up. Decorator, okay? So somehow the state pattern is more like strategies, like to me, this is not the official answer, but to me, the difference is strategy is like you have two ways of doing something, so you pass in the strategy. State is when you have a lot of different, um, it's too much to call a strategy. It's more like, it's just a lot of different possibilities, you know. Um, like I always think of state pattern, I always think of a game. Like you're in the weak state, you're in the strong state, you have a weapon state. Like I always think of a computer game when I think of state pattern, because that sounds like it's easy to keep your code clean by just saying, well, if I'm in this state, I can only do this. If I'm this state, I can only do that. Yeah. So it's more of a way of keeping it straight in your mind what's going on. Otherwise, you go crazy. Like, you have a million if statements. If you're in this power, then you could do this. If this, then this. If that state, do this. And then your code is a bunch of mumbo jumbo. But if you break up into states, then the code is easier to follow what's going on because there's so much stuff going on in the game, right? Okay. Um, the decorator. What does decorator do? The decorator does is it chains together multiple objects so that when one uh, when calling one method on one object, may trigger a cascade of a reaction where uh, where the same method may be called on multiple objects, on connected, on chain object. Um, okay, that's a little bit too technical, but I'll give you a simple example. Like if I call log on one type of logger, it may in turn call logger on I'm sorry, call log. No, it's like you have, let's say, 5 logging objects, and I can have them all connected. So if I just but I don't know that there's many objects. All I know is there's at least one, and I just say log, but behind the scenes, I could be calling the log on one object or 10 objects. But from my perspective, I just called log, right? And then so I don't have to worry about, well, oh, there might be 5 loggers or 10 loggers or only one logger, right? I'll just call log and whatever is chained together with the one I called, right? I guess that would be called the parent logger, right? Each one will call the next one. All the connected loggers. Okay. Okay, okay. It's a little bit hard. It's easier to explain, to give an example than to explain. Okay. But that's the idea. The idea is that I don't know exactly what's going to happen when I call this method, but I don't care, right? I just have to call this method and it might trigger a chain reaction. It's like dominoes. You just push the first domino. There might be one domino and there might be 100 dominoes, right? But you don't care. You're just pushing one domino, but there might be 100 other dominoes that are gonna I might have yeah, I might have tipped over, a whole bunch of other dominoes, right? Okay, everybody knows what dominoes is? It's a game where I don't even know what the point of the game, but is it really a game or just what?
I appreciate it. It's all line on YouTube. That's my.
Every video is something.
I'm not sure why but they have like dots on it. I don't know what the point of that. I don't know, maybe there are different ways to play it. Okay, anyhow, so memento, what does memento pattern mean? So memento is a souvenir, right? So it basically means that I'm trying to take a snapshot of another object and I am storing that snapshot in another object, right? So I'm actually going into that object, taking its values and storing it in another object because we like creating objects in design patterns, right? So that's what memento is. We take a snapshot of of an object and place them into another object. Called a memento object, which is then stored. Okay? So that's mementos. And then builder, we went through that and make sure that we don't create objects with bad data. And then singleton is what? What's the idea of a singleton? Yeah.
It's like one instance of an object.
Right. We only have one object, right? But the main idea isn't really the single part. It's more we're protecting it from unauthorized changes, right? Because we keep the global object private, and the only way you could access it is through certain methods which are public, right? So the idea is that we were protecting a global variable from bad values to make sure that there is only one object created. Okay, but that's really just the only one object created part isn't as important as the first part that we don't want it. We want it sort of like no, it's usually a global variable is a bad thing to have in a program because if it's public, because then it could get changed anywhere in the program and it's impossible to understand what's going on. So, you might change it here, you might break it over there. So normally it's a bad idea, but this is sort of like a attempt to make it safe. There's still people who say singletons are not a good idea because it's still a global, but but it's definitely a lot safer than a regular global. Like where I work, we still have globals and no one really understands what's going to happen if we change something. So we still have them. I got rid of a bunch of them, but uh, then people were getting nervous that I was getting rid of too many of them. So, but that's the idea is that globals are very, very, very bad, and they're very dangerous, and in fact, they're really hard to get rid of because it's hard to understand what, it's like for example, you'll see in one part of the code, someone sets the global to one value, and then someone else in another seemingly unrelated part is reading the global, and you don't know what was it something that someone did 10 years ago and no longer applies, or something that still applies? How do how do you test that? Right? Very difficult to get rid of. So, so never, in general, don't use globals. Even a singleton well, a singleton is usually read only, so it's a little bit safer, or it's a lot safer, but definitely don't use a global where you could write to it, because that is really bad. It's a, okay. Okay. The following is not part of a software development cycle. That's true, doesn't go up. Okay. Okay, so the following is not part of a software development lifecycle. So basically, we said daily meeting, that's part of what? That's part of Scrum, right? The daily meeting part. It's funny, at work we have it's actually also called a daily stand-up, really. It's called a stand-up. And the reason why it's called a stand-up is because we don't want people to get too comfortable. Right? Yes, I'll change that. That's really part of Scrum. And then we don't want to have a real meeting. We just want to have a quick meeting, right? Where are you doing? Are you stuck? Are you going to do, that's the idea of Scrum. Targeting rule is something I just made up. So analyze current system, that's always, right? That's for any software, right? This is for um, any software process has to do that, or I should say every. But you always have to analyze what you have. Feasibility study, that's also a good idea for every system. Or actually, usually I mentioned it. Well, I guess every system is a good idea. And then Scrum is, it's part of the software development, the iterative software development lifecycle, right? So the only thing is I made up number two. Okay. Uh, okay. It's very hard to think of fake things that sound right. Yeah. They aren't stupid. This is really stupid targeting me. Okay. I don't know if anybody got that wrong. Okay. Yeah, I don't know how they do in the SAT. They like I guess in math it's easy to do it because like you could think of the ways that people could do something wrong. So then it's easier to give multiple choice like in the SAT. Like
They gave the answer,
what?
like they gave the number, like minus 16 versus 16.
Yeah, like they think of the things that people would do, with mistakes they might make or yeah. Or the correct answer seems very unobvious. So something like that. I don't know. Uh, I find multiple choice are very hard to write. Okay, the following is not a good software practice. Um, so number one is this a good practice to use inheritance to handle different behaviors? Very bad, right? We said inheritance is very, very what? It's very um, um, what's the word? It's very uh, it's very coupled, right? Tightly coupled, right? The most tightly, right? Because it's is a relationship, right? So it's a little bit too strong of a way to reuse software, right? So is a relationship, and we said that is bad, is it's too strong. Okay. Strategy pattern is, yeah, that is a good software. Um, so one is definitely not good. Strategy pattern is good, right? Because yeah, by definition, we learned it, must be good. Um, Using composition to handle different behaviors, that is good also, right? That is actually the strategy pattern, right? It uses composition, meaning that um, it's a little funny the way they say it. But the idea is that composition means that it's a variable inside an object that um, could have different behaviors. That's the idea of composition, right? So, the idea is that within an object is a variable which could point to different behaviors. That's why it's called that's why they use the word composition, right? You're not getting the behavior from the parent, but rather it's a variable within myself. So I could change it, not use it. I have full control over it, right? It's not like inheritance where I am that, whether I like it or not. Composition means it's a variable inside of me, and then I could do whatever I want. Okay? I could, I could pass in different behavior. I could ignore it altogether, right? So I have control. Um, Using interface types for method parameters, that's always a good idea, right? By the way, which do you remember which object-oriented um, um, principle this is? That you should use interface type for parameters if you can. A long time ago. This is the dependency inversion principle, right? That we should always be as general as possible, right? So that way our code will be more, what's the word? Reliant? No, more uh, pliable? No, it's something like that. More flexible. What? Yeah, yeah, you're right, right, but yeah. In other words, it won't have to change when the parameters change, right? Because the more general the parameter type is, then the less possibility it needs to change, right? For method parameters. So this is the DIP, dependency inversion principle, right? Why it's called that is a whole story. Okay, so that's the fancy name for some simple idea. Okay, why they call it dependency inversion? It took me a long time before I figured it out. I saw it somewhere why he does it, why he calls it that name. Okay, so a state diagram. So Um, okay, so now remember, we're not talking about the pattern, we're talking about the state diagram, right? Okay, so remember what a state diagram looks like? So basically, let's find one on Google. So state diagram image. So let's just do for water. Okay, so So, okay, here, so. um, So for example, over here, you have plasma, I don't know. What is plasma? Does anybody know? You mean it could be hotter than 210? Is that it?
Yeah, it
Could be any temperature? And one of,
depends, I'm sure questions.
uh-huh. It's like, so it's superheated water, right?
Okay.
Well, okay. I didn't know. Oh, wow. So you could actually heat up water more. I guess so if it's contained. Yeah, what it,
Without water itself, so they can. One should electron. It's kind of weird, it's only because,
it becomes like a liquid?
not like electrons come out, like electron, it tears apart, so.
Uh-huh. So what does it do?
It sounds like plasma, you want to,
Oh, well, yeah, yeah, okay. So I never knew about the plasma when I went in school. Anyhow, so I just knew, I knew about the simple ones. Anyhow, so this is showing you that the point of this is that it's showing you the boxes are different states of the same thing. So you have the same molecules and it's showing you the different states that that water molecules or whatever you want to call them are in, right? The water could either be a vapor, water, if it cools down, if it gets really cold, it could become ice, and then if it gets really ionized, I guess, it could become plasma, and if it gets deionized, it gets back to water vapor. Okay, so basically the idea is it's a very it's focusing, well, it should focus on one object and it's showing you the different states that object could be in. So imagine this could be um a character in a video game. They could have a strong state, weak state, something like that. So the idea is that the arrows are actually called transitions because the the water is transitioning from one state to the next. Okay, so this is the um, state diagram. Okay, getting back to our question. So maybe I should just copy this to make it simple. Um, Now people go ahead and they make this really complicated. Um, but we're just doing the simple stuff. So see if I could paste this in here. Okay, C below. Let's just see if I could paste this in. Yay, okay. So focuses on changes to a system during program execution. Okay, that's one possibility. Okay, that sounds good. Let's see what the other ones are. Sequence of messages between objects in an interaction. Nah, that's not messages. What do we say those arrows are? Transitions, right? It's not objects either. It's the same object changing, right? So this is actually what is two? What is this really? This is really a sequence diagram, right? Right, that's really what this is. Three represents the goals of systems and users. Uh, yeah, so that's basically, we said this is the use. Yeah, I wrote in parentheses what that really is. Okay, so that's not a state diagram. How's the activities between the system and other actors? No, this is a, not how, this is a use case, right? The activities between the system and other actors. Um, right? So 4 would be a use case diagram. And then 5 is explanation of software written from the perspective of the end user customer. What is that? What is that? It's not a state diagram, but what is that really? Do you remember?
The use case,
A actually a use. Oh, no, it's a general. No, there's a use case table, which you would be right, but actually it's a user story, right? Remember that thing you put on a little card? Okay. So basically the answer would be number 1. So I'll make that bold. Okay. So that would be it. Okay. Next. The following is a functional requirement. Okay. Scalability. Okay, that sounds like that might be a non-functional because it's a general thing, right? In other words, we want our program to be able to grow. So we're not mentioning any specific, we're saying the whole program has to be able to scale, right? So that sounds like a non-functional requirement. Page color is something that it's like one thing, right? So that is that's specific to one feature, right? You want the page color to be this color. A business rule is also functional. A report is also functional, and a search feature is also. So the one that is non-functional is scalability, right? Because that's a general thing. Now, in general, anything that ends with a Y is a non-functional requirement, like reliability, um, uh, I don't know, usability, but usually things that end with a Y are usually non-functional requirements, right? Performance is a non-functional but doesn't end with a Y, but a lot of them end with a Y, right? So that's the clue. If you're not sure whether something's functional or non-functional, look for the Y. Okay. Non-functional with versus functional requirement. So we said, as I mentioned before, a missing non-functional requirement usually causes software to be unusable by the user. Is that true or false? What?
true.
No, it's false because the function requirement is like, for example, let's say I have Microsoft, let's say over here I have something here I could do, right? So let's say one of these things is missing. That doesn't mean I can't use the browser, right? I can still use it for most of it, except for maybe one of those things in here that I'm missing, right? Let's say the history doesn't work correctly, right? But the rest of it works. So usually a function requirement could just be done later on. But a missing non-functional requirement, that makes it unusable. So for example, if security, right, ends with a Y, right? So security, if that is um, missing, then who's going to want to use your program, right? Especially if it's a requirement like a company, right? You deal with social security numbers and stuff like that, right? So birthdays and all that what are they called? Personal PPI, something personal protected information, I think stands for. So if you're dealing with that stuff, you have to by law, I believe it's federal, I don't know which law it is, but definitely the European Union, right, has a bunch of requirements that if you sell software in Europe, you have to be very careful with all these things, right? So basically, if you're missing a non-functional requirement, then that means your program is dead, right? Like for example, performance, which is speed, right? If your program's slow, no one's going to want to use it. What? Yeah. Software performance is a function requirement. No, we just got through saying that's a non-functional requirement, right? Performance it's a basic thing. Web page background color is a non-functional, that's functional. Non-functional requirements are easy to test, true or false. That is false. Why? Because usually they're hard to quantify. Meaning like it's some like say like our program has to be secure. Well, what does that mean? Does it mean we need I don't know, the different encryption levels, right? Does it mean we have to use, like government encryption levels? Do we have to what? I'm sorry? I'm sorry? Right. It's right. Basically, how do you make sure that it's actually right? See, functional is easy to test because it's very specific. You just test it and it's good. But something like security, safety, like how do you prove it's safe, right? How would I prove no one's going to get hurt, right? So, um, so that's for it's more that is hard. You have to come up with ways to metrics. This is chapter 4, right? We have to think of ways how to create metrics to be able to test it, right? So for performance, you would say maybe that we have a 3-second turnaround time, from or, you know, for security, you might say we meet a certain standard. There's some companies that test software for a living. So you could say we're certified by this company, you know. Uh, Though I'm always suspicious of those things because you're paying them to test your software. Now, if they don't pass it, you're not going to use them. So how is that reliable? I don't know. I guess if they're big enough, then maybe they're reliable. But I definitely wouldn't trust a small company to certify because, they want the business. Um, so a lifeline is found in which diagram? We just did this. We just said it's a sequence diagram, right? So that would be the answer. Oh, by the way, over here would be number 2. Right. Okay. Which design pattern is shown in the code below? What does that look like? Well, actually, I should just made this private also. So it's more clear. This is a singleton, right? Because it has a global static. Static in Java means global. And we're saying if the first time we call it, we create one, the next time we're only going to use the existing one, right? So it's only going to use one session, right? This one session. So, and this is private, so it can't be accessed directly, right? Can't be changed. Okay. So that would be that one. So the answer to this would be singleton. So singleton, explain only one, um, session is created. Only one session is ever created. Okay, so that would be the answer. Simple, yeah, we don't have to make it. It's a very simple, okay? Okay, the diagram below is what would you say this? Was actually pretty simple because you see the arrows are called transitions, right? So basically we have a door and it can only be open or closed. Can't be open in the middle. You can't leave it open. It's either open or closed. And this is a what? Yep, state diagram. So the answer here would be a state diagram. And I have no idea what a timing diagram is, door diagram, use case, activity diagram, right? So it's a state diagram. Okay. It's very hard to make a state diagram because a lot of times you could argue it's really an activity diagram. You know, some people might not, yeah, so it's hard to think of one. I've found that difficult. Okay, this is actually from before the midterm. This is just like a quick way of this is showing uh, uh, um, um, a multiplicity between objects, right? And also it's showing inheritance. So which two objects inherit from another object?
Is it from the V
I'm sorry?
or checking and savings from the?
Right, from account. Very good. Right. And then we have the numbers, which say that, for example, a bank could have how many officers? Right, could have none, or it could have 200, right? Max. A bank officer could, how many banks could a bank officer work for? One, right? Because there's a one on this end, right? So the relationship between a bank officer and a bank is just one, right? And then how many bank officers could a customer have?
Zero to.
No, one. Because you go from customer to bank officer, they can only have one. Right? I know like with my insurance, I didn't like my broker, so I switched to another broker. So they made I had to make a whole big request you're only allowed to have one broker with my insurance company. So there's a whole big thing, and so. Yeah, the guy was yelling at me, "Why are you switching?" He was angry at me. He said, "Well, because he never got back to me." Is that a good reason? He went on vacation and no one ever responded. So I think that's a good reason. Um, so um, and then anyhow, so how many customers could one bank officer handle? Well, either between none, like when first get hired, they might have no customers, or they might have up to 1,000, right? They can't have, and a bank could have how many customers? Either none when it first opens up, or 200,000, right? That's the max customers, right? Okay, so, and then um, how many accounts could a customer have? A little bit tricky question.
One.
Well, they could have both checking and savings, and they both inherit from account. So the answer is 30, right? Right, the most they can have is 30, right? They can have 10 checking and 20 savings. And they're all accounts because they have a relationship, right? So what's the question? Uh, uh, I don't know I don't even have any questions there. Okay, we went through it. Okay. Match the terms on the left with terms on the right. So this is discussing which process you're going to use for which type of program. So the waterfall, remember, the waterfall is usually for what type of program? No, it's for a program where it's difficult to make changes after you begin. Usually because it's expensive, meaning like it's medical, it has to be certified. If you make a change, you have to recertify it, right? So you rather not change it, or you have a large group working on something. So if one group changes it, they're going to mess up the other groups. So the waterfall would, so what type of software would fit that criteria where it's expensive to make a change? That would be airplane flying software, right? Because right, because why is it expensive to make a change? Because the software has to be tested and certified, or somebody's gonna, somebody might get hurt. So that's four, right? Waterfall, we said. Okay, incremental process, we said allows changes more easily, not easily, but more easily, right? So that would be three. Software reuse is basically number two, using open source software. And then client server is nearly every email program in the world is a client server program. I think probably every program in the world, right? Uh, because you have the clients who are emailing each other, and there's a server which is, taking care of the email, right? Okay, then I explain what's the difference between authentication and authorization. I don't know why I threw it in here, but authentication means who are you, and authorization means what permissions do you have, right? So it's two different ideas. One is who are you, and then authorization is are you permitted to do this action, right? So usually most software, you won't even see the action that you're not allowed to do. No, it's usually if you can't do something, it just gets hidden and you never see it. It's not like you click it and it says, sorry, you can't do it. Usually you just won't even see it, right? That's usually so you won't even know that there was an option you could have had. Okay, let's just do two more. Which are attributes of good software? So acceptability sounds good. Dependability and security sounds good. Efficiency, that sounds good. Efficiency means what, by the way? It means that something's efficient, doesn't waste like computer resources, right? Doesn't, when your program runs, is all the memory in your computer doesn't disappear, right? That's efficient, right? Doesn't waste. It makes, maximum use of of the resources, as opposed to just being, a lazy programmer who just said, why not just use up all the memory? Maintainability is very important, is that you could fix the software. So the answer would be number four, which would be all of them. Okay? So they're all attributes of good software. And we'll do one more. Okay. In this diagram, I don't usually, by the way, do so many from before the I don't know why I have so much from usually I don't have as much from before the midterm.
Maybe you're thinking of what questions to include from the presentations.
What?
Oh, maybe you're gonna have a lot of questions from the presentations, right?
Only three true and false, like I did in the midterm.
Okay.
Yeah. Yeah, but I'm doing a lot more than I usually do from in here. I guess I did more than I usually do. Um, oh, here's an architecture question. Okay. The diagram above shows, okay, what does this diamond show? Composition. and this shows, I'm sorry, aggregation, and this shows composition, right? Which means that what? The driver doesn't necessarily have to belong only to a vehicle. A driver could be associated with other things. But composition means that the engine can only exist within the vehicle, right? That's what composition means. So this is showing us composition versus aggregation, okay? There's no inheritance here. There's no abstraction. There's no engine does not require a vehicle. No, it's not true. An engine cannot exist without a vehicle. Vehicle requires an engine. That's um, not really true. It's that engine could only exist within the vehicle, not the vehicle requires an engine, right? So the thing it does show is composition versus aggregation, right? That's definitely true. Okay, and dependency inversion principle encourages using interfaces as opposed to concrete types. That's true. Encourages code decoupling, which means that I should say, loosely coupled code. Yeah, this is a long time ago, so loosely coupled code, which is true. And specifies that high-level modules should not depend on low-level modules, which is basically what that is. This is the definition of why it's called dependency inversion principle. So that's a little bit not fair. So, but the answer would be all the above. Okay. Yeah. Okay, I'm going to ask this again, but or maybe it's 1 and 3. I don't know. It's not a good whatever. I'll just delete it.
So, also includes 1, 3, or both.
I know. I'll just okay. Just that. Forget it. It's a badly worded question. Okay. I give an example. Okay. I don't want to. Yeah. I don't want to. Basically, um, okay. So we here, for example, I don't know. This is um, uh, um, uh, I'm sorry. Interface, database, or just database, and then class SQL Server implements database, and then with database. Okay, so basically in this code over here, where I'm using SQL Server as a type, I should rather use database to be more generic. Okay, that's the basic idea, right? So SQL Server SQL Server should be replaced with the more generic database. Okay, so that's okay. So there should be. How do you do a cross out? I don't even know. Control what? X? No. How do you do a cross out? Do you know a line through it?
Oh, like going on
I don't know, I have to go way up. Oh, 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 cool.
and then it's like,
Uh,
if you keep going all the way to the right. Of the actual document,
oh, here it is. They don't have it. I don't see it.
it's like a drop down menu, I think if you have to keep. going-
Okay, whatever, but that's the idea. I don't. Okay. You get the idea, right? Okay, that we want to replace that with, we want to replace this with the more generic database because SQL Server implements database. So why not use database instead of SQL Server, right? Okay, so we'll continue, hopefully after the Sunday after Memorial Day, like 7 o'clock. I'll send out
Professor,
yeah.
are the topics listed at the end of this document the only topics we have to know for the final?
I'm sorry?
The topics listed at the end of this document. Can you-
It's too loud wait, let me just lower. Yeah, say it again.
No, I'm saying the topics listed at the end of the documents, are those the only topics we need to know for the final?
did you understand?
So there's like a list of topics at the end of the doc.
Oh,
There.
there's a list of topics here? Oh, I didn't even, uh, uh, oh, here, finally we get to architecture. Oh, yeah, this is, from chapter 4. Yeah, this is the topics, right? But it's also, I added, uh, uh, I added stuff from chapter 9, a bunch of things. Okay?
So we only have to know this, right? Like
What?
this stuff. We only have to know this stuff from this
Yeah, but
list.
basically, if you go through all the folders,
Okay.
you since the midterm, but even from, a little bit before the midterm. I mean, the basic stuff before the midterm. I'm not asking a lot of questions from before the midterm. I think 70% will be from after the midterm, I would say. So, uh, but you should know this stuff from chapter 9. What is the seam? What is the side effect? When should you fix the code? When should you re-engineer the code? When should you replace it? Right? At what point, right? So you fix it, and basically, um, it's really simple. And re-engineer it when it's really going out of date, and you replace it when it's really, falling apart. What is a legacy system? Does anybody know what that means?
it's like outdated rules.
Yeah, basically it's your old system. Like every legacy, every system a day old. You buy a car, it's a legacy car. It's a day old. Yeah. So basically, a legacy system is what you have now, and usually it's old, right? Because your business uses it. What is the biggest problem with the legacy systems? Do you remember that?
Like developers will no longer look at it,
Say again?
like developers will no longer support the issues.
Or why not? You mean they don't know the language, you mean?
Oh, it's more like it's a waste of time for them to look at it.
Why would we wait?
Oh, because they want to sell the newest software.
They what?
Like they intentionally want to sell the newest software.
No, 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 but the biggest problem with legacy systems is, I actually, I didn't say the question correctly. With replacing, I should say. What's the biggest problem with replacing legacy systems? That's really what I wanted to say. What's the biggest problem? To get rid of it?
Like, they could be needing it still,
Say again?
something might require it. Still.
Well, I mean, the biggest problem really is it's not really the technology. It's the question is what does it do? Why does it do what it does? In other words, no one usually, it's been around so long. The people who wrote it left the company a long time ago, and now people are stuck with this program, and no one remembers why it does certain things. So when you look at the code and you try to see if you find another system to work the same way, or write a new system even from scratch, right? But you don't even know why the program's working the way it is, because no one remembers, right? So that's the biggest problem, is that within the program, there's a lot of business rules and stuff like that. And it's hard to know which stuff are important and which stuff is, was just left there and it's not being used anymore, stuff like that. So that's a big problem. Like I have somebody where I work, he always says, if we're not sure about something, get rid of it. And then we find out, oh, there was a reason for that. Like about a couple months later, somebody says, hey, how come this stopped working? Yeah. But his philosophy is, if you don't know why it's what it's doing, then get rid of it. Uh, and uh, and then we mentioned at the end of, I think it's uploaded, the document, it should be uploaded. We mentioned there's like 4 stages, 4 parts of maintenance, right? In other words, if you're not going to get rid of a replacing, we said there's 4 things, which is simple. Corrective means to fix. Adaptive means to make it work with the environment. And then um, perfective is to add more features, and preventive is to, like changing your oil so the car doesn't fall apart, engine doesn't break. So the same idea that you want to do, if you can, do some preventative things so that the program will keep going. Like so we have all those slides which give you all examples of all those things. Okay? So those are the things I'm adding from chapter 9. Okay? Um, okay, so I'll send you an email and we'll continue doing this and maybe some other stuff. But I just advise you just to go through all the folders. Email any questions you have, and I'll try to get back to you, okay? And good luck. Okay. See you.